Hey guys, welcome back to another video of me teaching, and today I have this question on the board for you guys. Although there are no sources for this question, this is a super popular question and can be found in many books and textbooks. So why don't we just get into the question? So we have a1 squared plus b1 squared plus c1 squared blah 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 blah, and then it's equal to a squared plus b squared plus c squared plus d squared. We have to find a, b, c, and d in terms of these. So how do we do that? Well, one way is, theoretically, we can just unpack the whole thing and then we try to make 4 squares, but theoretically this should work. But that's not what we're going to do because that is a bit silly. So, well, remember when we're dealing with super hard math questions that seem like they cannot be solved, we always go to the simpler cases. So one of the most simplest cases is when there are only 2 terms. So when there are only 2 terms, then it'll be a1 plus b1 squared times a2 plus b2. Oh my god, I keep forgetting the square. Well, we have to prove that this is equal to a squared plus b squared, and we have to find what a and b is. Well, of course we can unpack this because now it's simple, but we don't want that when we have 4 sums. So, well, one question that I really like asking to you guys is, what does this look like? Well, isn't this just a perfect form of a complex number? You take the modulus, then you square it, right? But which complex number? Well, of course, a1 plus b1i. So, the left-hand side become, this I said is a1 plus b1i modulus squared. And then multiplied by, here, do the same logic, it'll be a2 plus b2i modulus squared. Okay, what's next? Well, multiplying 2 moduluses is the same as one big modulus and inside are the 2 products. And you can verify this on your own. So it will become squared. Okay, so how does it help? Well, this actually helps a lot because if we can split it into its real and imaginary part, won't that be something plus something? And you modulus square, it will be that squared plus this squared, right? So if we separate it into its real and imaginary forms, then we'll get the real form is obviously a1, a2, but then it's this times that, I times I is -1, so it's minus b1, b2. And then we have to add it with, so the imaginary part, a1, b2 plus b1, a2, I modulus squared. And we know that the modulus squared of this is easily this squared plus this squared, so this is the A and this is the B. Easy. But how do we do that with 4? Well, I will show you how to do that now. So, to do the one with 4 adding ups, thanks to Mr. Hamilton, we can use something called the Quaternion. So, do you know how complex numbers extended the real numbers to a 2D plane? Well, now we're going to extend the complex numbers into a 4D whatever. So, if you're not sure what a quaternion is and you want a very visual guide, make sure to watch Brown's video about quaternions. It's super detailed and very fun to watch. So, anyways, what is a quaternion? Well, like I said, a quaternion is actually in 4D, so I can't draw it out for you guys. But the layout is really similar to a complex number. So the layout is basically, if a complex number is a plus bi in 2 dimensions, then we just add 2 more dimensions by adding cj and dk. So this is an example of a quaternion. Well, I first have to go over some identities of a quaternion for you guys. So, just like complex numbers, we have I squared is equal to j squared is equal to k squared is equal to -1, and this is also equal to ijk. Okay, another thing, this is where stuff gets kind of confusing. So we're going to draw kind of a wheel. So I goes at the top, j to the left, k to the right. Now, there are 2 ways to spin this wheel, either anti-clockwise or clockwise. Now, the relatively simpler one is anti-clockwise, so I'll explain that first. So, you go this way, this way, this way. So, well, the identities are I times j is equal to k, right? So this is an identity. Then you keep on spinning the wheel. J times k is equal to I. Spin the wheel one more time. K times A is equal K times I is equal to J. Now we're going to spin the wheel clockwise. So we spin it this way. Right? So this means that I times K is equal to, well, I times K is not equal to J, since quaternions are not commutative. I times K is actually negative J. So if it's clockwise, just remember everything's negative. So I times K is equal to negative J. Then K times J is equal to negative I. Then J times I is equal to negative K. Okay, so I'll actually just keep these identities on the board, but I'll rub out this and this. So, this in mind, we can use the quaternions to solve this equation. So, we see that the left-hand side will be, well, what is this? Just like the last example, the so-called easier example, this is actually the modulus of a quaternion squared. So, the modulus of A1 plus B1I plus C1J plus D1K squared times the next one, A2 plus B2I plus C2J plus D2K modulus squared. And likewise, to the last example, we see that the product of 2 modulus squared is equal to, inside one big modulus is the product of these 2. So it will be A1 plus B1I plus C1J plus D1K times A2 plus B2I plus C2J plus D2K, then modulus squared. So here's where things get complicated. We'll separate this into the real term, the I term, the J term, and the K term. And in total, we're going to write down a total of 16 terms. So let's go. This will be equal to. Okay, the first bracket is going to be the real terms. So it will be, the easiest one is A1 plus times A2. A1, A2. And then, like complex numbers, I times I is equal to -1. So it will be negative B1, B2. Then, likewise for the J's, so negative C1, C2. Same logic for the D's, D1, D2. So this is it for the real section. And then we have to add the I part, which will be, well, the easiest one for the I parts is easily A1 times B2. And, of course, A2 and B1. And this is where we use the identities. So we want to know the I term. We know J times K is equal to I, so we find J and K. So plus C1 D2. But we aren't done yet, because we still have the negative term, which is just K times J. So we have to subtract. We find a K and a J. So D1 C2. And I. And then we have to add. Okay, now we have to add the J terms. So again, the two easiest, A1 C2 and plus A2 C1. And then plus. Okay, so for J, we have K times I is equal to J. So we find K and I. So we plus D1 B2. And then, don't forget the negative term. I times K is equal to negative J. So you subtract, find the I, find the K. So negative B1 D2. Then we add again. Last one, guys, the K term. Again, the two easiest, A1 D2 and A2 D1. And for K, we have I times J is equal to K. So we find the I and the J, so it's B1 C2. And again, don't forget the negative term. J times I is equal to negative K. So you subtract, find the J, find the I. So subtract C1 times B2. And write the K. I forgot the J here. J. And then don't forget to take the modulus and square it. Okay, so I will not write this is equal to this squared plus this squared plus this squared plus this squared, because I don't want to. So I'm just going to tell you guys that this is equal to A. I forgot the I here as well. No, this is real. Sorry. And this is B. This is C. And this is D. And let's see, do we do the question in terms of A1 blah 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 blah? We did. So this is the end of this super amazing question. Well, thank you guys so much for watching, and if you enjoyed my video and you want more videos like this, please consider liking and subscribing. If you want to master something, teach it.